Hello, I Dr. Kirti Sahu welcome you all to this very important video lecture on Laplace transform. We have studied about the various concepts and the applications in the previous classes. Here I am going to discuss the multiple choice questions on Laplace transform which are frequently asked in the various competitive exams such as SET, NET, GATE, University and many more. So let us start with the first question. The inverse Laplace transform of the function is required, and these are the four choices given. So whenever the question is asked regarding the inverse Laplace transform, so the learner should know the inverse Laplace transform as well as Laplace transform of the elementary functions. So that is the prerequisite in order to answer these questions. As well as learner should be aware of the various methods to find out the inverse Laplace transform. As this is the function which is nothing but a rational, so that's why we will first opt for the partial fraction method. So we can get the answer very easily. So let us see how we can get the answer. So consider this function. The denominator is already factorized into linear factors. So we will write the partial fractions and then we will go for the values for a and b, which we know very well how to get the values for a and b. So here on applying the set of process, we get a as 2 and b as minus 1. Substituting this, we will have such type of expression, and we know that if I wish to take the inverse Laplace of this, so inverse of 2 upon s plus 1 is nothing but e raised 2 times 2 is constant, and inverse of 1 upon s plus 1 is e raised to power minus t. Similarly here this comes out to be e raised to power minus 3t. So in this way the correct option is option number A. Let us have the next set of question. The Laplace transform of e raised to power alpha t into cos a t is. So if you observe here, we find the product of two functions, out of which one is an exponential term. So for such type of function, we have a property that is nothing but a shifting property. So in order to avoid the confusion with this, I have written the Laplace transform of shifting property in this way, that is Laplace of e power bt into f of t is f of s minus b. So here we will first identify b. What is b? B is nothing but alpha and f of t is cos a t. So we will quickly find out the Laplace transform of f of t, that is cos a t. According to the formula, it is s upon s square plus a square, and the b is alpha. So as soon as we get f of s, everywhere replace s by s minus b. So what it will be? S minus alpha, b is nothing but alpha, so s minus alpha upon s minus alpha whole square plus a square. So in this way again we are getting the correct choices, option number A. Now let us have the next question. The next question is, if f of s is s plus 1 to the power minus 2 is the Laplace transform of. So we want to know in other way what is the inverse Laplace transform of this. Okay, so option given are this. So let us find this. So for this we will have the property for inverse Laplace transform just now which we have used here is the first shifting property. So in terms of inverse I can write it like this, that is L inverse of s minus b is e power bt into f of t. So first of all, from this s minus b we will remove b by writing it as e power bt. So here s minus b will come out to be what? Minus 1. So we will have e power minus 1 times t, that I am observing only in the option number C. So that's why option number C is the correct one. If suppose you will find two choices where you find the term e raised to power minus t, then what is the next process to be adopted? So then we will find out the inverse Laplace of the term which is obtained after removing b from this function f of s. So I'll remove this plus 1 term from there. So I am left with s to the power minus 2, right? So we will just find out the inverse Laplace of s to the power minus 2, that is nothing but according to the formula inverse Laplace of 1 upon s to the power n is nothing but t to the power n minus 1 upon n minus 1 factorial. If you will use that, you will get it as t. So that's why option number C is the correct option. So in this way one can get the inverse Laplace as well as Laplace transform. Let us have the next set of question. So see here I am having a product of two functions, out of which one is a nothing but a unit step function. So in order to get the Laplace transform of such function, the only thing which one should remember is the property of the Laplace transform, that is Laplace of f of t minus a into u of t minus a is e raised to power minus as into f of s. Okay, so what we will do here, so we will express first of all this function in this form. So I am having t minus a, that is t minus 1. So I will express this in the form completely as everywhere t as t minus 1. So what I will do, in order to write that, I will use the trial and error basis method. Otherwise we have the other method also that I have mentioned completely clearly in my video lecture on unit step function. If you wish, you can go through it, right? So completing the square, we just need to add 1 and then subtract the same term. So you will have plus 1 minus 1, sorry, here it is u of t minus 1, right? That I missed out. Okay, now first 3 term is nothing but t minus 1 whole square. I'll multiply with u of t minus 1 and then minus 1 times u of t minus 1. Okay, so this we have. Now you can see everywhere I am having a function of the form this. When I am having u of t minus a, the function attached with that is a function of the form t minus a. So that I am getting. Now quickly we will take the Laplace transform by using this property. So you need to identify a. So a is nothing but 1, right? So by using this property, what you will get, e raised to power minus s. Then remove 1 from here, t square is left. Take the Laplace transform of t square, that is 2 by s cube according to the formula. Then here again a is 1, right? So we will write e power minus 1 s. What is left over here along with this unit step function? 1. Okay, so Laplace transform of 1 is nothing but 1 by s. So in this way we get this which we find in the option number A. So in this way we get the answer. So the basic formulae and the various properties of Laplace transform one should remember, will make the task easier, right? So if f of t is a periodic function, so it is just a elementary problem. For this, the only requirement is that you should remember the formula correctly, right? So this is nothing but here, if a periodic function is given, so the Laplace transform of periodic function formula is required. So what is that? So it is 1 upon 1 minus e raised to power minus st. Remember, this t is nothing but a period of that function. If I'll write period by say capital U, so you should write here U, right? The integral 0 to that period again, that is t, and then we have e raised to power minus st. This is completely a function of t, right? Small t, or the variable of integration. If suppose I will write variable of integration as say x, so it should be e raised to power minus sx f of x dx, right? So the option given are little bit confusing, but if you remember the concept of remembering the formula, right, so you will definitely obtain the correct option. Okay, so this one is the correct one, that is option number A again. Now the Laplace transform of a plus bt whole square, where a and b are constant, is given by. So sometimes what happens, the people have concept in their mind that t is getting transferred to the s, right? Function of t is getting converted to the function of s. So whenever they observe such type of options, so sometimes by mistake they choose the option number A, but it is not like this. T is not getting converted to s. Function of t is getting converted to function of s. Okay, so this is not the correct one. Many times students select this option number A. So what to do in this case? So what we will do? So obviously we have to take the Laplace of this. So first of all we will expand this. We will express it in such form where we can know the Laplace transform of each and every term, right? So that is this one, just applying the formula a plus b whole square. Now we will take the Laplace transform. So we will arrive at the option number C as a correct one. Okay, so very easy, but sometimes due to the wrong concept, the students marks the wrong answer, right? So concept must be very much clear. Okay, the next one. If Laplace of f of t is this, then the value of limit as t tends to infinity of f of t is required, right? So these are the 4 choices given. So as the limiting value of this f of t for t tends to infinity is required, so we will first work for evaluation of f of t, right? So as Laplace is given, so when we take the inverse Laplace of this, we will get f of t, right? So inverse f of t is nothing but inverse Laplace of s upon s square plus omega square, which according to the formula is cos omega t. And once we get f of t, let us take the limit as t tends to infinity of f of t, that is cos omega t. And we know that value of cosine when t tends to infinity always lies between minus 1 to 1. It could be any value between minus 1 to 1. Don't know exactly, but it is always a finite value, right? So answer is finite, but none of the option gives this choice, right? So it means it should be cannot be determined. It cannot be 0, it cannot be unity, or it cannot be infinite, but it is value between minus 1 to 1. Okay, so that's why we will go for the option number A, that is cannot be determined. Let us have the next question. The Laplace transform of delayed unit impulse function delta of t minus 1 is given. It is required. So we will simply use the formula of Laplace of delta of t minus a. Here Laplace of is required, right? L of delta of t minus a is what? E raised to power minus as. So here a is, if we will compare, so what we find, a is 1, so that is e raised to power minus s. So Laplace of, here note that correction, that it should be Laplace of, okay? So it is e raised to power minus s. Then the next is inverse Laplace transform of 1 upon s square plus s is required. Again it is a rational function. So as I told you in the beginning that we will go for a partial fraction method if it is applicable. So that will give us the option number C is the correct one. Let us have the last question of this, that is the inverse Laplace transform of 1 by root s is, right? So how to find out that? So it is obtained simply by making use of a standard formula, that is L inverse of 1 upon s to the power n is t to the power n minus 1 upon gamma of n, right? If n is any real number except a negative integer, okay? So we will apply that. So here n is nothing but under half, right? We can write under root of s as s to the power half and put everywhere n as half. So we will have such type of term. It is t to the power minus 1 by 2, that is 1 by root t, and then gamma of 1 by 2. What is the value of gamma of 1 by 2? That is root pi. So we will have the simplification as 1 by root pi times t. So that is option number B. Okay. Now the final one, that is the Dirac delta function. So here one should be very much clear about the definition of delta function. So what is delta function? It is nothing but the response obtained at infinity for a short interval of time, right? So here it is required at t equal to 0, right? At t equal to 0 it is required. So t equal to 0 here we find, and response is very high, that is what? Infinity, and 0 otherwise, okay? And this condition is obviously required. So that's why this is the correct one, right? So option number D is the correct one. So I'll come up with the few more important example in the next lecture on Laplace transform. Till then, keep watching, keep learning. Thank you all for watching the video.